All right, starting lesson 1.10, mathematical modeling and variation. All right, so very simple. Direct variation. Direct means you are multiplying. So here are a number of different ways of making essentially the same statement. Y varies directly as x. Y is directly proportional to x. Y is equal to kx for some non-zero constant k. All right, so for example 1, assume that y is directly proportional to x. Use the given x value and y value to find a linear model that relates y and x. All right, so y is equal to k of x. All right, so it just means that you're multiplying these values. K represents a constant. All right, now they give me values for x and y, so I plug those in. And I could solve for my k, which is 7. So plugging it back in to what I originally had up here, I get y equals 7x. And that's all there is to it. Example 2, simple interest. All right, so they tell you the investment is directly proportional to the amount of the investment. All right, $5,000. You've invested. Okay, and you obtain $187.50. Okay, so here I'm investing, and the interest that I earn is directly proportional, all right, to the amount of the investment. The amount of the investment is P. This is known as your principal. So how much did I invest? $5,000. All right, and for I have $187.50. All right, that's how much interest I earned. All right, so let's divide by 5,000. All right, you can use a calculator for this. K is equal to 0.0375. All right, and so rewriting my formula now, the interest is equal to K, which is my constant, or in other words, my interest rate in this case, times the principal. All right, there's your formula for this particular situation. All right, going on to the next example. All right, now I'm working with direct variation as the nth power. All right, so once again, a bunch of different ways of stating the same thing. It says find a mathematical model for the verbal statement. V varies directly as the cube of E. So V varies directly, so it's equal to. Now there's always a constant involved. So it's going to be K, and then we have as the cube of E. So E cubed. Cubed means raising it to the third power. And that's all they wanted you to do there. Done with that. Example 4. Write a sentence using the variation terminology to describe the formula. All right, so essentially we're going backwards here. So S represents the surface area. So the surface area of we're talking about a sphere. S, using the variable, is what? Let's use our statements. Directly proportional to, now what's happening here? Now these are just numbers. 4 pi is essentially our constant, so I'm just focusing on the variable and the exponent. To the square of the radius r. All right, that's all there is to that. Going on to the next example. All right, now we're talking about inverse variations. And when you're talking about inverse, you're simply talking about division. All right, now once again, here's 3 ways to state the same thing. And for example 5, find a mathematical model for the verbal statement. H varies inversely as a square root of S. All right, so H is equal to, you always have your constant, and varies inversely means we're dividing. So as the square root of S, so it's simply the square root of S. All right, that's all there is to that. Example 6, we're going backwards once again. So we say the volume V of enclosed gas is directly proportional, okay, to, all right, well, here's just my constant. Don't need to say anything about that. To, and I said directly proportional because t's on the top and I'm multiplying by that. So to t. And then what else is happening? I'm dividing by p. So what's going on with your variation there? Then it's, you would also say, and what's happening? And is inversely proportional to, what's on the bottom? P. All right, that's all there is to that. Going on to the next example. All right, joint variation. Joint variation just means you're including more variables, and all you're doing is multiplying. So once again, 3 ways of stating the same idea. Example 7, find a mathematical model for the verbal statement. Z is jointly proportional. Okay, Z is jointly proportional. That means since it says jointly, I'm going to have 2 variables that I'm multiplying. Z is jointly proportional, so I always have K in the mix. That's my constant. Is jointly proportional to the square of X and the cube of Y. All right, once again, jointly means I'm multiplying. So that's all there is for that. And for the next one, find a mathematical model representing the statement, find the constant of proportionality. V varies jointly as P and Q, and inversely as the square of S. So inversely means I'm dividing. All right, so let's just replace this with some values now. I have 1.5 is equal to K. I'm solving for K now based on the information that they gave me. Divided by 1.2. Oh, and I'm missing something. They said the square of S. So don't forget to square it. Okay, and then I end up with 1.5 equals K times 17.9. So divide by 17.9. And for K, I get what? 0.03? 0.083? And that's all I have to do, because what did they ask me to do here? Find the constant of proportionality. The constant's K. Got it. Done. All right, that's the last lesson of the chapter. Make sure to ask questions if you have any. I hope you didn't leave any lingering questions. All right, let's make sure to fill in all the gaps of knowledge. Make sure you understand everything at this point. And begin the assignment at the bottom of the webpage.